Hello students, in the last session we completed around 8 to 9 sums. Those sums were mainly related to the concept of molarity, molality and then the moles, isn't it? Same way, in this session we will complete rest all other sums. So you got around together, you got around like 35 sums. In this session we need to do somewhere around like 13 to 14 sums. We will do all those 13, 14 sums. So this will be the last session, PYQ session for this chapter. Got it? So in this session also we'll have sums that will be related to molarity, molality, same thing. And we will also do that 21, 22, 23. These 3 year sums will also be done. Got it? Okay, so now let's see the next sum, which is like 23rd one. Here you have got 1 gram of magnesium, which is burnt with 0.56 gram O2. Okay, so you are having like magnesium solid and I'm burning it in the presence of oxygen in a closed container vessel. So the product that is formed over here isn't getting dissipated to the surrounding. Okay, that's the case. Which reactant is left in excess and how much? What they're asking us to find is if this reaction is going to get completed 100 percentage, and that was the case, what will be the reactant that will be left, whether magnesium is left or oxygen is left. So here you have got like one of the reactant to be excess when compared to the other reactant, right? So here one of the reactant will be limiting. Let me find out which one is less, which one is greater. So something that is excess has to be found out, either it could be magnesium or oxygen, and I will also have to get the grams, like how much amount of magnesium or oxygen that is excess in that container. That too has to be found out, right? Let me first write the equation for this statement. So here you have got like magnesium, yes, and I'm going to burn it. Magnesium is going to get combined with the oxygen and then it produces magnesium oxide. Okay, so Mg, so this is divalent, therefore MgO. This will be the product that will get formed. Fine, if I do balance this equation, this chemical reaction, you'll have 2 in the front, same way you'll have like 2 in the front with respect to reactant and then the product. Now the chemical equation is balanced. Next, what I'll have to do is I'll have to get which reactant is left in excess. I'll have to get the reactant that is excess, right? First, let me figure out how many moles are there in 1 gram of magnesium. That is something that I need to get. Same way, I have to get like how many moles of oxygen is there in the 0.56 gram of O2, right? So that will be the mathematical part which I need to do. So here, with the case of magnesium, you have got like 1 gram, and they have given you the atomic weight of magnesium, which is like 24, isn't it? So 1 divided by 24 will be the number of moles. So 1 gram. So I have done the ratio stuff straight away. So 1 gram is the amount that I have taken. 24 is equal to 1 molar mass, isn't it? So 1 by 24 moles of magnesium is there. Got it? So if I do have to solve this one, how will I be able to do it? Now let me do the division for it. So 1 divided by 24, isn't it? So add 1 0. So put 0. That too will not work out. Add 1 more zeros into it. Put 1 more 0. So you have got like 100. If it was like 100, yeah, 25 into 4 will give you like 100. So that's going to be like 96. So you will have 0.05, isn't it? 0.0, no, 4. 0.04. Yeah, you will have like 4 and then you will get like 40. Even in this situation, you'll have like 24, isn't it? So 0.041, and then this stuff goes on. Yeah, if I do the approximation, obviously you will have 0. The next number will obviously be greater than 5. I hope so. Therefore, let me approximate it to 0.042. So this was the number of moles that was available with the case of magnesium. So here you have got 0.042. Fine. So the first, for the magnesium it is done. Next I'll have to do the same thing for the oxygen, isn't it? If I have to do it for the oxygen, you will have something like this. Now let me get this one. Next, let me do it for the oxygen. With the case of oxygen, you have got 0.56 gram, isn't it? Yeah. We have got 0.56 divided by its molar mass. For oxygen, it is like 16. Here you have got like O2, therefore that should be like 32, isn't it? Yeah, 32. Yes, right. If I do have to solve this one, how will I be able to do it? Yeah. Let me put it this way. Same way, let me do the division. Let me do it straight away. You've got like 3200, and then in the numerator you'll have like 56. No, I'm just writing it other way now. I'll have to take the division, isn't it? So here you will have 5600 divided by 56 divided by 3200, isn't it? If I have to solve this one, let me first put 1 0. This thing is also not divisible, therefore let me put one more 0 into it. So now I'm just ready to do the division, isn't it? Yeah, 5600. So here 3200. Yeah. 32 into 2 will give you like 4, and then you have got like 64. That too will not work out, isn't it? So let me do straight away with 32 itself. So 3200. Here you'll get 1. Here you will get 3200 divided by 0 zeros. And then you will have 4 2. 2400. So this thing is not divisible. Therefore, let me add one more 0 into it. So you have got like the 24,000. Just one more decimal place that I need to get over here. Yeah. What will be the best? 3s are 7. Let me match it with 7. Yeah. If I match it with 7, you will have 32 into 7. That will give you like 14. 1 over there. 21. 2, 2. Yeah. This will be the closest match. 22400, isn't it? So the next decimal place that I need is like 0.017. Yeah. Yes. So the number of moles of oxygen that was present is actually equal to 0.017. Yeah. So here it should be equal to 0.017. Fine. Now I just know these both concentration are not proportional to each other. Something is excess. Fine. So if I have to get that stuff, just by looking at the number, it is pretty obvious. When compared to oxygen, you need to have double this amount, right? If I'm just going to double this one, if I multiply it with 2, and then this number was equal to this one, then in that situation, these two stuff will get completely reacted, and the entire reactant will get completely reacted, and it will form the product, isn't it? But in this situation, I know this is excess, because when you do multiply this one with 2, you'll get like 3 2 something like that 3 2 or 3 5. But here you have got like 42, obviously 0.042. So here if I just look at it, it is pretty clear that magnesium seems to be much more greater when compared to that of the oxygen. So here the limiting reactant is actually the oxygen, so this will get completely involved in the reaction when it proceeds, isn't it? So I'll have to multiply this by 2, and then I'll have to subtract with 0.042 to get the excess amount of moles of magnesium that was present. Once I get the excess moles of magnesium, obviously I'll be able to get the weight of it. So here it is pretty clear. The reactant which is left in excess is going to be magnesium. It's not the oxygen. Okay. Now just let me do the, once the reaction proceeds to completion, here if you look at this, you'll have like 0, isn't it? Initially reactant will be completely available, there wouldn't be any product. After the completion of the reaction, the magnesium will be equal to 0.042. Yes, so that's the excess quantity minus 0.017 into 2. Yeah, right. Once I do subtract this one, I'll end up getting the excess. Oxygen will get completely involved in the reaction. There wouldn't be any remnant left. Therefore, for oxygen, the final was equal to 0. Same way, the amount of, yes, so the amount of MgO that has been formed will be equal to this one, right? So this was, it's like double the amount of magnesium, double the amount of oxygen has been formed, isn't it? When you look at the stoichiometry, it is clear. This is like 1. Here you have got like 2. Then actually double the amount of moles of magnesium oxide has to be formed when compared to that of the oxygen, right? Based on the stoichiometry, I'm just doing it. You should be clear. So here the amount of magnesium oxide formed will be equal to 0.017 into 2. I'm not worried about this multiplication. Only stuff that I need over here is this one. Yeah. Right. So let me do this calculation. You'll end up getting the answer. That's it, finished. So if I do subtract those two stuff, first let me do the multiplication. If I do the multiplication, you will have 0.017, yeah, right, into 2. So we'll have like 14, 1, 3, 0.0. Yeah, I'll have to subtract this one with 0.042, therefore 0.042. While doing the subtraction, you'll get it clearly. Once you do the subtraction, if the answer was like positive, then it is clear that one was excess. If you get like negative, then you have subtracted it other way around. That's the intuition that you need to know. Here 0.042 subtracted with 0.034 will give you the answer. Therefore here you will have 12 and then 8. Here we'll have like 0. Yeah, 0, one more zeros into it, 0.008, right? Now I have got the number of moles of magnesium that was excess. Next, what I need to get over here is the weight. They're asking us to find the weight, isn't it? So to get the weight of magnesium, just multiply it with its molar mass, you'll get the answer. 0.008 moles of magnesium was there. Multiplied by the molar mass will give you the weight of the magnesium that was actually found over there. So the atomic weight is 24 for the magnesium. So you will have multiplied by 24, right? Just do the multiplication, you'll get the answer. So here 24 times 8, that will give you 32, 3, yeah, and then 16, 192. Got it? Then I'll have to move the decimal places. So I'll have to move 3 decimal places towards the front. So I'll have like 0.192. So the answer is, for the magnesium, the answer will be 0.192 gram. So this is something that I need to find it. So this is the approximation stuff that I've done, isn't it? When you look at the option, either it should be like option 1 or it should be option 3. Fine. So in this case, option 3 isn't possible because it is much farther from the 0.192 that I've done. But when you look at the option 0.16, that will be the closest approximation. Here I've just approximated to like 2 figures, significant figures, something like that. But if you just find like extra one more digit into it, like 3 digits into it, then you will get value that is closer to 0.16. Got it? So I have just made, if you have to get the exact 0.16, what you will have to do is you'll have to find one more value in this division. So if you get like one more value in this division, somewhere this mole will come close to some other number. So when you do the multiplication, you'll end up getting 0.16. But in the situation, as I've done the approximation, that's like slightly greater. That's the thing. Therefore, when you look at these two options, it should be clear. 0.44 isn't possible. Okay, so 0.1, it should be around that value. 0.1, it should be that value, but this is like 0.4. I haven't approximated to such an extent. Therefore, it should be obvious. Option 1 should be my answer, right? Therefore, the answer over here is 0.16 gram, which is like option 1, right? You shouldn't have any doubt on this question. Same way, this question is simple, but the problem is with the mathematical solving. So this question is actually a time consuming one, but yeah, the understanding and the logic behind it is actually simple, right? You shouldn't have any doubt on this question. Let's move on to the next one. This question is based on the concept of molarity. Here they have given you 6.02 into 10 per 20 molecules of urea are present in 100 ml of its solution. Fine, so they have given you the number of molecules. I'll have to convert it to the moles. What they're asking us to find is the concentration of the solution. Is generally, when they give you the term concentration, it actually means they are asking us to find the molarity. You'll get used to this term in the upcoming chapter. As of now, it might be a new term, but whenever you get this term concentration, it means they are asking us to find the molarity, or they have given you the molarity, capital M. Okay, right? Now let me solve this one. So this is simple, easy one. What was the formula for the molarity? Number of moles of solute divided by volume of the solution in liters. Yeah, here they have given you the number of moles of solute in terms of molecules. So I'll have to get the moles from it. If I do get the moles from it, I'll be able to do it straight away because I know the liters. It is like 1 by 10 liters, right? Let me do it over here. So to get the number of moles of solute, simple sum, easy, straight away. Okay, so here I'll have to get the x moles for 6.02 into 10 power 20 molecules. We know 1 mole will be equal to 6.02 into 10 power 23, isn't it? Just do the solving, you'll get the answer. 6.02, these two stuff will get cancelled out. Same way, this one will get cancelled out, and then you will be left with 10 power 3 in the denominator. If it comes to the numerator, you'll have like 10 power minus 3 moles. So this was the mole that was actually dissolved into that solution to get a final solution of 100 ml. Yeah, so once you so if I have to get the molarity, I just need to get the molarity of the concentration, isn't it? So to get the molarity, number of moles of solute will be equal to 10 power minus 3. That will be in the numerator. Same way in the denominator, you will have 100 ml. So 100 ml is 1 by 10 liters. You should be clear by this time. So 1 by 10. So this stuff will also go to the numerator. So you'll have like 10 power minus 3 multiplied by 10. That will give you 10 power minus 2 capital M. The answer here is the molarity will be equal to 10 power minus 2 capital M. Got it? So 10 power minus 2 capital M will be 0.01 capital M molarity, which is like option 4. The answer here is option 4. You should be clear with this question. This is a simple question, right? Straight away simple question. Here they have just given you the number of moles of solute or solute, something like that. What they're asking us to find is to get the molarity. Just divide by its volume of the solution, you'll get the answer. Got it? It should be clear. Let's move to the next one. This question is a little bit tricky. Here you have got, in an experiment, it is showed that 10 ml of 0.05 molar solution of chloride required. Okay, so here I have taken like 10 ml of some chloride solution. They haven't mentioned anything regarding the cation. It could be magnesium, silver, whatever it is, but they have just clearly told us it's a chloride solution, and I have taken 10 ml of that solution. The molarity of this chloride solution was equal to 0.05 m. Okay, then required 10 ml of 0.1 solution of AgNO3. So if I'll have to mix these two stuff, and the other one is AgNO3 solution, and that solution has a molarity of 0.1, and then I have taken like 10 ml of that solution. I'm just going to mix these two stuff. Which of the following will be the formula of the chloride? What I need to get is, once this rearrangement happens and then the final product gets formed, so how should be the chloride? Okay, so how should it actually combine with that element X? That's what I need to get. So X stands for the symbol element other than the chlorine, which means once the reaction got proceeded, initially in what fashion that X has to be combined with the chlorine. That's what I need to get it over here, right? So I'll have to get the equation. Got it? So to get the equation, I'll have to balance that equation based on the stoichiometry. So to do that one, first I need to know what moles of, as usual, what moles of chloride was there in this 10 ml solution. With respect to 1 liter, you will have a mole of 0.05 moles, but in this situation I've just taken 10 ml, right? So in this 10 ml, what mole of chloride was actually present? That is something that I need to get. Same way I'll have to get it for the AgNO3, right? When I do compare um, these two availability, I'll be able to figure out like how many factor does one of the reactant was greater. So based on that one, I'll be able to get in what combination that got actually combined with the cation. The chlorine got combined with the cation. It could be XCl2 or it could be XCl3. So that pattern could be figured out over there, right? So here these two reactants are going to get combined, and once it get combined, you will have like displacement reactions, or those stuff will you will have like a interchanging of cation and then anion, and the reactant will be, and the product will be formed from the reactant, isn't it? So that stuff will happen. But here what I need to find is in what fashion does this chlorine got combined with this unknown element, unknown cation. That is something that I need to get, right? So to get this one, what will I do is I'll just find the number of moles. Once I know the number of moles in these two solutions with respect to the chloride and then the nitrate, I'll be able to get, I'll be able to relate it in such a fashion. Yeah, how should the combination should actually be there, right? So once I do it, I'll get it clearly. Anyway, you should be clear with the idea that I'm telling you. First, find out what was the moles of AgNO3 and then the chloride that was there in that solution. Just once you get that stuff, if you just compare it, just find the multiples of it, you'll end up getting in what fashion does this chlorine has to get combined with the cation over there, right? So let me do it, you'll get it. So fine, first, let me do it for the chlorine. Yeah. So first, let me do it for the AgNO3. Whatever it is, it doesn't matter. Let me do it for AgNO3. Yeah. How much amount of AgNO3 was there in this 10 ml solution? So to get that one, if it was the same ratio logic that I'm going to use it over here. So here, the unknown is like n. So I have to get the n for 10 ml, right? So for the 10 ml, you will have, if I have to convert it to liters, you'll have like 10 power minus 2, isn't it? 10 ml will be equal to 10 power minus 2 liters. If it was like 1 liter, you will have 0.1 moles of AgNO3 into it, right? Got it? So here n will be equal to, so here for the AgNO3, n will be equal to 10 power minus 3, fine, which means it will be equal to 0.001. So mole was that. Okay. Next, I'll have to get for the chlorine, isn't it? So you'll have some unknown X and then the chlorine. Okay. So this is what I need to get. So here, this cation, either it is like monovalent or divalent, that is something that I need to get. With respect to chlorine, I know it is like monovalent, right? So if it was like divalent, then double the chlorine would have attached to it. If it was like trivalent, then triple the chlorine would have attached. That's what I need to find. So if it was like divalent, two chlorines would have attached. If it was monovalent, it should be like XCl or X2Cl2. If it was tetravalent, then XCl4. So it could actually depend. It could actually change depending on the condition. So here you have got like X and then Cl, chlorine should get attached to it. I just need to find out that what will be the valency for that unknown cation. That's what I need to get, right? But in this situation, first I'll have to figure out how much amount of this chloride is there in this 10 ml solution. So I'll have to do the same thing that I've already done with the case of AgNO3. So N will be equal to the ml that I've taken. So that will be 10 power minus 2, same way divided by 0.05 0.05 with the case of 1 liter, right? If I do the cross multiplication, you'll have n. If I do the cross multiplication, you'll have n that should be equal to, yeah, that will be equal to 0. Let me put it this way, 5 into 0.5 into 10 power minus 3, isn't it? Yeah. 0.5 into 10 power minus 3 moles. Okay, that will be handy because I'll be able to compare these two numbers. So if I have to compare these two numbers, it is obvious. Here this, if I just do the division of these two stuff, okay, so here this one is greater when compared to this one, because this is like 10 power minus 3, this is like half times 10 power minus 3, half times 10 power minus 3, therefore it should be obvious this one is greater. If I do divide 10 power minus 3 divided by 0.5 into 10 power minus 3, obviously I'll end up getting n to be like 2, isn't it? Which means I have got like double the times of AgNO3 when compared to this chlorine. Okay, so this reaction got completely proceeded. There wasn't any remnant left with the case of the reactant, and that was the case, and then it formed the product. Okay, so if that is supposed to be the case, I took AgNO3 double the times when compared to this chloride. Okay, now I'm just ready to figure out the X combination with the chlorine. For that, I'll have to first write the chemical equation that is needed over here, right? Chemical reaction that is needed over here. So you will have AgNO3. Okay, that was taken like double the amount. I just compared it over here. So when I do the comparison, AgNO3 is double the times when compared to this one. So therefore, you will have AgNO3 plus some XCl. Okay, that's gonna give you something. That's gonna give you like AgCl and then XNO3. Okay, so first here this quantity is double the times when compared to this one. So that is when this reaction is going to proceed, isn't it? So if this is going to be double the times, let me put the stoichiometry in front of it. So you should have 2AgNO3. Yeah. So if it was like 2AgNO3, I know the chlorine valency is like 1. So depending on this valency of the X, the number of chlorines that's going to get attached with this cation is going to change. So here you have got like 2AgNO3. Same way here, you should get this 2AgCl. Then obviously you should have like 2 chlorines in it, right? That is when this reaction will proceed. Yeah. So I just need to have like 2 chlorines because 2AgCl is the only possibility to get formed over here, because I've taken like 2 silver over there. Okay. Yes, right. So if that's gonna be the case, then obviously here you should get this 2. Yeah. So we should have this 2. This one should be clear. You should have this 2 over there. Then this X is a divalent atom. It should be like magnesium, Mg2 plus, something of that sort. Okay. So here this stuff is done. Now I'm just ready to balance this NO3. So here I've got like 2 NO3s into it. So this is divalent, isn't it? Therefore, here also, let me put 1, 2 underneath it. Now this equation is balanced, and I also figured out in the reactant, the cation that I've chosen is actually divalent, which will give you the chemical composition to be in the pattern of XCl2. Got it? So I just figured out that one based on this comparison. So when I do compare these two stuff, it was clear. So I just need to get this unknown factor. Let me name it Y. So if I have to get that unknown factor, how will I be able to get? I just have to figure out which one was greater, and then I'll have to divide it with the moles that was lesser, right? So when I do that stuff, you'll have like 10 power minus 3 divided by 0.5 into 10 power minus 3. So here it was like 10 power minus 3, 10 power minus 3 got cancelled. 0.5 was like 1 by 2. Therefore, you have got like 2, which means there was like double the amount of AgNO3 moles when compared to that of this chlorine. Okay, so if it was like double the amount, then obviously here this should be a divalent. That is when, actually, because this silver is monovalent, therefore here it should be divalent. That is when this chlorine will be able to match with this silver, because I've taken double the amount of AgNO3, right? So that's the intuition and thinking that you need to know. So this question is a little bit tricky. It is tricky. Okay, so here we are just, generally they'll give you the equation and I'll end up finding this number of moles and other stuff. But here what they have given us is, they haven't given the equation. They're asking us to find whether this cation is monovalent or divalent. So I'll have to go the other way around, which the generally I used to solve one way. Here I'll have to go the backwards, right? So to move backwards, I just found the number of moles for both those cases and I just compared it. When I did compare it, I figured out that one of the parameter was double the times of this one. Then obviously that's the hint that I needed. So when I know that hint, I was able to compare. So this should be double, then this should be half of that one. So here I just put the stoichiometry 2 in front of it, then rest other things just will come out by itself. So here if it was like 2, then here also you should have the 2. If you have like 2 over there, then I'll have to balance this one. So to balance this one, I'll have to put like 2 chlorine. Then obviously this is like a divalent atom. And then EXNO3 twice. That's it, finished. That the reactant was also found out. So now I'm just done with this answer. So the answer over here is XCl2, which is like option 2. Got it? You shouldn't have any doubt on this question. This sum is like a little bit lengthy. It should be clear. Let's move on to the next one. This sum is simple one. Here you have got 25.3 gram of sodium carbonate, Na2CO3, is dissolved in enough water to make 250 ml of solution. So you have got like sodium carbonate to be 25.3 gram. That's what I've chosen over there. Okay. If sodium carbonate dissociates completely, molar concentration of sodium ions and carbonate ions are respectively. If I just completely dissolve into it, what will be the molar concentration? So they're asking us to find the molarity with respect to the solution considering the ions. Got it? One will be like Na plus ion and the other one will be CO3 2 minus ion. One is like cation and the other one is anion. They have given us the molar mass straight away. So in this situation, they are asking us to find the molarity with respect to the ions. So it should be clear you will have like double the molarity for the sodium, because when one molecule of Na2CO3 dissociates, we will end up getting two molecules of sodium. Same way we will have like one molecules of carbonate. Okay, so the molarity of the molar concentration of sodium is will be double the time when compared to that of the carbonate. Yeah, so if you just compare it over here, yeah, you should get this one. So the answer is like pretty clearly it's like option 2. Okay, because this should be double the times. So when you look at this one, it is like other way around, that's not possible. Same way if you look at the option 2, it is double the time when compared to this one. So option 2 should be my answer. Same value isn't possible. Yeah, here also like, yeah, this one is also not possible, right? Because these two stuff are very closely related. Therefore, option 3 is also 1.90, 1.91. Both are just the same thing. That too is not possible. Same way, option 4 is also not possible. Just by looking at this logic itself, I'll be able to mark the answer, which will be option 2. Anyway, let me do the sum. Fine. First, let me find out the molar concentration for Na2CO3. Got it? So you will have, let me write the equation. You will have Na2CO3. So this was the sodium carbonate crystal that I dissolved into the solution. Okay, so this is the solute. When I dissolved it, it produced Na, 2Na plus, and then CO3, 2 minus ions, right? So this is very well soluble. Therefore, once it dissolves, it will produce like 2Na plus and CO3, 2 minus ions in the solution. Yeah, the amount of sodium carbonate that I've taken over here is like 23.5 gram. Got it? If it was like 25.3 gram, first I'll have to get the number of moles in it. Yeah. So to get the number of moles of Na2CO3, I just know I have taken 25.3 gram divided by, yeah, divided by its molar mass, that should be equal to 106. Yeah, 106. Fine. If I have to solve this one, how will I be able to do it? 25.3 divided by 106, isn't it? 253. Let me make it this way itself. 253. 10. So you'll have like 1 zeros into it. 0 point. If I add like zeros into it, let me do it with the multiples of 2. 1060 into 2, you'll have like 0, 12, 2120. Yes, that is possible. Therefore, you'll have 2120 over there, 2120 over there. So that will give you 0.2. So if I do cancel this one, 0, 1. Here we'll have like 4100. If I have to get like 4100, it should be like 0.24 or 23, something like that, right? So that closest approximation will be 0.24 moles. Yeah. Now I have got the number of moles of Na2CO3, that will be equal to 0.24. So now I have got the number of moles of Na2CO3, that was equal to 0.24 moles. I just dissolved to produce like 250 ml of the solution. Got it? Yes. If you have got like 0.24 moles with this one, okay, initially these two stuff will be 0, isn't it? Once the dissolution is completed, you'll have like 0 amount of Na2CO3 into it. Same way, you will have like double the times of this one, that will be equal to 0.48. Yeah, this will be same as that of this Na2CO3 that I've taken, so that should be 0.24 itself straight away. The logic should be clear. Yes, if this is supposed to be the case, then I have to get the molar concentration, isn't it? Now I'm just ready to get the molar concentration. So molar concentration will be, I'll just find it out for CO3. Yeah, Na will automatically follow. So for number of molarity of the CO3 is something that I need to get. So I need to get molarity of CO3 2 minus, which will be equal to number of moles of solute, which is going to be CO3 2 minus, that has to be in the numerator. That will be like 0.24 divided by Yes, I'm just done. Milliliters, right? I'll have to substitute in liters for the molarity. Volume of solution in liters. The solution was like 250 ml. If I have to convert it to liters, that will be like 1 by 4 liters, right? It should be clear. So 1 by 4 liters. So the answer will be 4 into 0.24. Yes, so I'll have like 16, 0.96, isn't it? 0.96, yeah. So the molarity of carbonate ion will be equal to 0.96 capital M. Yes, so the answer is 0.955. That was like 0.96. So this stuff is correctly matched. The double the time of this one will give you for the sodium ions, isn't it? So if I multiply it with 2, I'll end up getting 1.910 capital M. Right? You should be clear. This is easy sum. Yeah, you shouldn't have any doubt. Let's move on to the next one. This sum is also a simple one. Here you have got 10 gram of hydrogen and 64 gram of oxygen were filled in a steel vessel and exploded. So you've got like 10 gram of hydrogen and then 64 gram of oxygen. Obviously, when these two stuffs combine, it will produce water, isn't it? That will be the byproduct. That will be the product. Amount of water produced in this reaction will be. So I just need to get what will be the amount of water that will be formed. Okay, it could be like 3 mole, 4 mole, or 1 mole or 2 mole. So first I just need to get how much amount of moles are there in 10 grams, and same way with respect to oxygen. So one of the reactant is going to be limiting, so based on that I'll be able to get the number of moles of water that has been formed. Fine, first let me write the equation. The equation will be H2. Yes, it's going to react with O2. That will give you double the amount of, no. Yeah, that's gonna react with, that's going to form H2O, isn't it? So if I have to balance this one, I just need to put 2 over there. Same way, here you'll have like 2H2. Got it? The equation is balanced. Yes, now let me find out H2. So here H2, the gram that was present is like 10 gram. Got it? So in 10 gram, I know in like 2 gram you'll have like 1 mole. Here it is like 10 gram, therefore it should be like 5 moles. I'm just doing it straight away. It should be clear. Then with the case of oxygen O2, you have got like 64 gram. Okay, so here obviously it is like 64 gram. In 32 gram you'll have like 1 mole. It's like double the amount, therefore here you'll have like 2 moles. Yes, I just found out how many moles are there. So here initially it was like 5 moles, it was like 2 moles. Here it was 0. Yes, if I just look at this one has to be double the amount. If I'm just going to double this one, you will have like 4. 2 will react with 4 moles of H2. Yes, 2 moles of O2 will react with 4 moles of H2, but you have got like 5. Then obviously this is oxygen will be the limiting one. Okay, so after the reaction has completed, you will end up having 5 minus 2 into, that will give you like 1 mole of hydrogen in it. Oxygen will get completely reacted. Finally, you will end up having double the amount of this one, right? So 2 into 2, that will give you like 4 moles of H2O that has been formed. Okay, so the answer here is 4 mole, which is like option 2. Option 2 is the answer, right? It's like 4 mole. You shouldn't have any doubt of this question. Simple one. Let's move on to the next one. This question is also simple one. Let me read it. How many moles of lead chloride? Okay, so they have given you the valency of the lead. It is like 2. Lead will exhibit multiple valency, plus 2 and plus 3. Here they have given you it's like divalent in this condition, in this situation. So this is like lead chloride will be formed from a reaction between 6.5 gram of lead oxide and then 3.2 gram of HCl. Okay, so I'm just going to do the reaction between lead oxide and then the HCl, and what they're asking us to find is how many moles of lead chloride is formed. Got it? Here I'll give you the atomic weight of this lead. That will be equal to 207. So that will be the molar mass. Do not want to worry about this atom mass, I mean like molar mass, because anyway in the question they will give you, that will be a square bracket and they'll give you the atomic weight of lead and things of that sort. These were like very old question. In those years, they didn't give it, right? Do not want to worry about in this current situation. If that element was something odd, they will give you the atomic weight. Do not want to worry about that one. Okay. Here I have given you straight away that will be equal to 207. Got it? These stuff need not be memorized. That's what I'm telling you. Let me write the equation. The equation over here is the lead oxide, okay, PbO, is going to react with HCl, and then this is going to form PbCl2 because that's divalent, okay, lead chloride. Pb, it's like PbCl2 plus, yes, H2O, isn't it? Yeah, H2O. Yeah, I'll just move this one a little bit towards the left. Now I'll just substitute the stoichiometry into it. Yeah, if I have to substitute that one, you have got like two chlorines into it. Therefore, here it should be like two HCl. Yes, H2 and then O. That's it. The equation is balanced. Yes, yeah. So what they're asking us to find is how many moles of lead chloride is formed. Same way, I'll have to get the number of moles of lead oxide and the number of moles of HCl, and then I'll have to get which one is limiting. If I do get that one, I'll be able to get the number of moles of lead chloride that has been formed. That's it, finished. Okay. Division will be the problem over here also. Mathematical solving will be lengthier. Anyway, let me do it. With the case of lead oxide, with the case of lead oxide, you have got 6.5 gram, isn't it? 6.5 divided by the 207. Okay, 6.5 gram divided by 207 gram will give you the number of moles of lead oxide actually that got present in it. So if you do the division of it, you will have 65. Yeah, 2070, 0 point, add one more zero. Yeah, one more zero. So you will have, if you have to solve this one, you will have 2070 into multiplied by, yeah, 3. Yes, 0. 7 into 3 will give you like 21. Yeah, right. 6210. So here you will have 6210. Yes. So that will give you 3 over there. I'll just find one more decimal place. So you will have like 0. Yes, that's gonna be 10. So 10 will be like 9. 4, that will give you 2900. Yes, if it was like 2900, that will be 0.31. Yes, that's gonna be 0.031. Got it? So the number of moles of lead oxide that was found over there was equal to 0.031. So lead oxide is done. Next, I'll have to get it for the HCl, right? So let me find it for the HCl. So I've got like 3.2 gram of HCl in it. Then for the HCl, you have got like 3.2 divided by chlorine will be equal to 35.5, and then one hydrogen has to be added to it, so that's going to be like 36.5. Okay, so 36.5. I'll have to do the division one more to get the number of moles. If I have to do the division, I will have 3 2 32 divided by 365. Yeah, 0.0. That doesn't work out. Add one more 0 into it, so I'll have like 0 over there. Yeah, 3200. 365 into 9. Let me multiply it with 9 and just 365 into 9. 45, 4. Yeah, you have got like 6, 54, isn't it? 54 plus 4 will give you like 8, 5, 27, 27. Then you'll have like 3, 2, right? 3, 2, 8, 5. 3, 2, 8, 5. Yes. So I'll be able to approximate this one to 0.08. Okay, something like that. 0.08. If I do approximate that one, I'll end up getting 0.09. Okay, so 0.09 will be a closest approximation. So let me take it 0.09 itself. The moles of HCl that was found over there was equal to 0.09. Okay. Yes, this stuff is done. So now I'm just ready. So the number of moles of lead oxide over there was equal to 0.03. Number of moles of HCl over there was equal to 0.09. So if you just look at this, yes, this will react with double the amount of HCl, isn't it? So this can react with 0.03. Yes, so this can react with 0.06 moles of HCl and the entire reaction will get completed, but HCl is there in excess of extra 0.03 moles. Therefore, here the limiting reactant will be lead oxide. So if I have to figure out, so lead oxide will get completely reacted, right? So the final, initially this will be in this fashion, isn't it? Initially this will be like 0.03, this will be 0.0900, and once the reaction gets completed, you will have lead oxide that will get completely reacted. Same way here it will be something like this, double the amount, isn't it? So 0.06 minus, I mean 0.09 minus 0.06, so that will give you, I'll just write it straight away, 0.03 that would have been formed. Same way here, if you just look at it, here you'll have like 0.03 moles of lead chloride that has been formed. Same way here also you'll have like 0.03, right? That's it. I'll have to match it over there. So the closest one is actually 0.029. So the answer here is option 2, right? This one has to be clear. You shouldn't have any doubt in it. This is a kind of same pattern sum that we have already seen, right? Let's move to the next one. Next is the mass of carbon anode consumed. Okay, and it gives only carbon dioxide in the production of 270 kg of aluminum metal from the bauxite by the Hall's process. Okay, so bauxite is actually the ore of aluminum, and the chemical formula for the bauxite is Al2O3, right? In upcoming chemistry chapters, you will learn this bauxite stuff. So here you have got Al2O3, and then what I'm going to do is I'm just going to do electrolysis. Okay, so you'll just pass current into it, and then you'll have like anode cathode into it. Here you have got like carbon anode which will get consumed in this reaction. Aluminum will be deposited. Fine. So this is how I extract aluminum from the bauxite. So this is a ore of aluminum bauxite, Al2O3. This will react with the carbon anode, and then it will produce aluminum and then the carbon dioxide, right? So giving only carbon dioxide, they have told us clearly. So the byproduct, so the end product over here will be carbon dioxide. Okay, yeah, so you've got Al2O3, and then this is going to get reacted with carbon, and then it will give you aluminum. Yes, and then carbon dioxide, and carbon dioxide will be evolved. Fine. So if you look over here, you'll have like 2 times aluminum, isn't it? Now I have to balance oxygen also, isn't it? So I'll have to make it even numbers. So let me put it this way. First, let me balance the oxygen. So 2. Here you'll have 6. So if it has to be 6, then obviously here it should be like 3. So that is when this will get balanced. So you have got like 3 carbon. So 3 moles of carbon. And then with the case of aluminum, we'll end up having 4 moles of aluminum, right? Now the equation is balanced. What they're asking us to find is the mass of carbon anode consumed. That's what I need to get. The mass of carbon anode consumed in the production of 270 kg of aluminum metal. If 270 kg of aluminum metal is produced, then how much amount of carbon will get consumed? That's what I need to get in this case. Okay, so first I'll have to match first I'll have to figure out how much moles of aluminum is there in 270 kg of the aluminum. Okay, so to get that one, what will be the atomic mass of the aluminum? They've given us straight away. It is like 27. I've told you, right? They'll give it in brackets. For tougher element, they'll give you the atomic mass. Anyway, here for the aluminum, I just need to find number of moles of aluminum in 270 kg. Number of moles of aluminum in 270 kg. So to get this one, in the numerator you will have 270. I'll just convert it to gram. That will be handy. Into 10 power 3 gram divided by 270 into 10 power 3 gram divided by the molar mass of the atomic mass or the molar mass of the aluminum. That's going to be like 27. So this will give you the number of moles, isn't it? Let me do the cancelling step. So you'll have 100 over there. No, 10. How about that? It's like 10. 10. So you will have you'll have like 10 power 4 moles of aluminum. So here I have got like 10 power 4 moles of aluminum. So if 10 power 4 moles of aluminum is needed, then how much amount of carbon has to get consumed? That's what they're asking us to find, right? So here they've given you 10 power 4 moles, right? First, let me take the simplistic situation. X moles of carbon anode is needed. How much amount of carbon anode is needed to produce 10 power 4 moles of aluminum? We know that if 3 moles of carbon got consumed, we will be able to produce 4 moles of aluminum, right? So just do the rearrangement, you'll get the answer. Therefore, x will be equal to 3 by 4 into 10 power 4. So 3 by 4 is like 0.75, isn't it? Yeah. 0.75 into 10 power 4. If you just play with the decimals, here x moles will be equal to 7500 moles, isn't it? So the amount of carbon that is needed in terms of moles will be equal to 7500. So the first part is done. So 7500 moles is needed. What they're asking us to find is in terms of kg, in terms of weight, they're asking us to find, right? So we know 1 mole of carbon will be equal to 12 grams, isn't it? So 7500 into 12, if I just multiply it with 12 grams, I'll get the mass, right? So 75 into 12 will give you the answer. So let me do the multiplication. 75 into 12, 10, 1, 14, 15. Then you'll have like 75, 0, yes, 5, 0. This will give you like 1, 8, 9. So 900 gram. Is it right? Yeah. So 75 into 12, right? So 900, and then you have like 2 more zeros into it. So this much amount of gram. So if I convert it to kg, I'll have to remove like 3 decimal places in it. So if I do that one, you'll have like 90 kg. So the answer over here is 90 kg. So that much amount of carbon anode is needed to produce 270 kg of aluminum. The answer over here is option 3, right? It should be clear. You shouldn't have any doubt. Simple sum. Yeah, even solving is also easy. Let's move to the next one. This sum will be a little bit annoying. Anyway, it will be easy to solve. Let me read it. Molarity of liquid HCl if density of solution is 1.17 gram per centimeter cube is. What they're asking us to find is actually the molarity of the solution. So what will be the molarity? Molarity is nothing but number of moles of solute divided by volume of solution in liters. Okay. So here they have given you like something called density of the solution. Fine. So don't overthink here. Okay. So here they have given you like density of the solution, which simply means you have got 1.17 gram of HCl in 1 centimeter cube of that solution. Okay, so that's how you have to understand or imagine this thing that they have given over here, right? So do not want to worry about that mass by volume and all those stuff. Just take it straight away. You don't get these kind of question in recent years. Anyway, as I'm just doing question till 2000, I have just included this one, right? If you get such a question, such a kind of question, just be clear that here 1.17 gram of HCl. Don't take that H2O and all those things in the solution. Just consider you have got 1.17 gram of HCl in this 1 centimeter cube of that solution. Fine. So to get the number of moles of HCl, what will I do? To get the solute, what will I do is number of moles of HCl will be equal to the gram that was there, which was equal to 1.17 gram divided by its molar mass, right? What will be the molar mass over here? For hydrogen, it is like for chlorine, it is 35.5 plus 1 will give you the molar mass of the HCl. So that will be like 36.5 gram. Okay, so this will give you number of moles of HCl. Okay, and then so now I'm just ready to get the molarity, isn't it? That's what they're asking us to find. So molarity will be equal to 1.17 divided by 36.5, and then I'll have to divide this entire term by volume of solution in liters, right? Here I know I have got like 1.17 gram in 1 centimeter cube, isn't it? I have got like 1.17 gram in 1 centimeter cube. So I have to convert this 1 centimeter cube to liters. If I have to convert that one, I know 1 liter, I know that 1 liter will be equal to 1000 centimeter cube. I just need to get how many liters will be there in 1 centimeter cube, isn't it? So just flip it, I'll get the answer. So x will be equal to 10 power minus 3 liters, isn't it? X will be equal to 10 power minus 3 liters. Got it? So that will come to the denominator. So divided by 10 power minus 3. So if I just divide it one more time by 10 power minus 3, you'll have like into 10 power minus 3, right? So this is the molarity that they're asking us to find. Okay, so if this term goes to the numerator, you will have you will end up having 1170 divided by 36.5. Just solve this one, you'll get the answer. Let me approximate this one to 36 itself. Okay, yeah, you'll get the answer. So here you have got 1170, and then in the denominator you have got like 36, right? If I have to solve this one, 36 will give you 36 into 4. Let me try with 4. So 36 into 4, 6 4 7, yeah, 24 to 12, 144, isn't it? Yeah, that thing will not work out. Yeah, so 36 into 3, 36 into 3, this one will work out 18, 1 9 108. Yeah, so here in the for the first division you'll have like 108, and in the quotient you will have 3. Yes, fine. Same way here, if I cancel this one, you'll have like 17. That will give you go to 0. So 17 will be like 990 for the next one. So 90, I'll have to use like 2. I've got no other option left. So 36 into 2, 36 into 2. That will give you like 12, which will be like 1, 6, 7, 72. Right? So here you'll have 72. Yeah, we have 32. Then yeah, this will be like 10. This is 8, 180, something of that sort. So I'll put one decimal place and you'll have like 32.4 or something like that. So 32 point something, 32 point something will be the option 3, right? So here I've just made this approximation, isn't it? 36.5. Therefore, the closest value here is 32.05. That should be my answer, which is like option 3, right? So this sum is a kind of vague sum. Okay, they have given you the density, and from that density, I just took it straight away. That was the amount of HCl that got present. Fine. So that's an really vague consideration that I've done over here. So this is the only way how you could actually solve this sum, right? You shouldn't have any doubt on this question. Let's move to the next one. This sum is also easy one. If needed, you can pause the video and try it by yourself. Let me read this question. Volume of CO2 obtained by the complete decomposition of 9.85 gram of barium carbonate BaCO3 is. So I just need to get what was the volume of carbon dioxide that got produced. In terms of volume, I have to find it. If I know in terms of moles, then obviously 22.4 liters will be equal to 1 mole. With that ratio stuff, I'll be able to get the volume of carbon dioxide that got produced, isn't it? Yeah. First, let me write this equation. So you'll have barium. You have got barium carbonate. That's gonna produce barium and then the carbon dioxide, isn't it? Barium. Yeah, it will decompose and produce barium oxide and carbon dioxide, right? Fine. It should be clear. What I need to get is how much amount of carbon dioxide is formed, isn't it? So I need to know, first I need to know the molecular mass of this barium. I'll give you straight away the atomic mass of the barium, which will be equal to 137. Fine, do not want to worry about this atomic mass. Okay, they will give you in the question itself. On really old times, they don't give you this one. You do not want to memorize these atomic masses or molar mass. Okay, so here the molar mass of barium was like 137. Now just find the overall molar mass of molecular mass of that molecule. So it will be equal to 137, and then for the carbon that should be like 12. For the oxygen it's like 16, so that will give you like 48, right? So 48 divided by that's it. Let me add it. 10, 17, 1, so you'll have like 8, 9, 197. So the molar mass of this barium carbonate was equal to 197 gram. So to get the number of moles, what should I do is 9.85 divided by 197, isn't it? 9.85. 9.85 gram divided by 197 will give you the number of moles. Yes, absolutely. So if I have to solve this one, you'll have 985 divided by 19700, isn't it? Yeah, first let me put 10 and then you'll have 0 over there. It doesn't work out. And then let me add one more 0. So now it will work out. So let me try it with multiples of 5 or 4 because this is close to 20,000. This one is like 98,500, right? So 5 will be a good approximation, isn't it? To get close to this 98,500. So let me multiply 19700 into 5, isn't it? 0, 0, 35, 3, 45, and then 8, 4, 9850. Oh, wow. I just got it straight away. So it should be like 9850. So that will be 0.05. That's amazing. So here it was equal to 0.05 moles. Okay, so that was the amount of moles that was there in this barium carbonate, which was 9.85 gram, isn't it? So here you have got 0.05 moles of barium carbonate. Then it would have obviously produced 0.05 moles of carbon dioxide, isn't it? Now I'm just going to multiply it with the molecular mass of this carbon dioxide. So to get the molecular mass of this carbon dioxide, that should be like 32 plus 12. Yeah, right. So that will give you like 44 grams for the carbon dioxide. So 0.05. No, I just don't want that one, right? So here I'll have to find the volume, isn't it? So to get the volume, what should I do? I'll have to compare it with 22.4, right? So 1 mole. So X volume should be equal to 0.05 mole. Then I know 1, no, 22.4 liters. 22.4 liters will be equal to 1 mole, right? If this was the case, then what should be the volume occupied by 0.05 moles of carbon dioxide? That's what I need to get over here. So that will be equal to X, which will be equal to 0.05 into 22.4. Fine. Yeah, I'll have to do one more multiplication. 22.4 into 5. Yes. So this will give you 5 is at 20, 2, 10, 12, 1, 10, 11. 11, 112.0. I'll have to move like 2 decimal places ahead. So you'll have 1.12 liters, right? 1.12 liters. Yes, I got the answer straight away, which is like option 2. Right? It should be clear, right? Only the division part was tough. You shouldn't have any doubt in this question. Let's move on to the next one. From now onwards, you'll get sums from the year 21, 22, and 23. You got around like 4 sums from these 3 years, right? Let us do the sums. Yeah, all those sums will also be easy. Do not want to worry about it. So 32nd sum is an organic compound contains 78 percentage carbon by weight. Okay, so which means you will have, if you take like 100 gram of that compound, 78 percentage, which means 78 gram of that compound will be carbon, right? Same kind of sum that we have already seen in the last class. Carbon and remaining percentage of hydrogen. Okay, so 78 percentage is carbon and remaining percentage will be like 22 percentage, that's going to be hydrogen. What they're asking us to find is the right option for the empirical formula of this compound is. So I have to get the empirical formula. The same kind of sum we have seen in the last session. So I'll do the same method. You'll end up getting the answer, right? Let me solve it. You can also try by yourself. So here it's like 78 percentage, which means 78 gram, isn't it? First I'll have to get how many moles are there in 78 grams of carbon. If I get that one, then I'll be able to match it with the 22 gram of hydrogen. Obviously in 22 gram of hydrogen you'll have like 22 moles of hydrogen atom, right? Got it? So first I'll have to verify it only for the carbon, then automatically this answer, you'll end up getting the answer. For the carbon you have got like 78 gram, that's what they have given in the question, and then divided by 12 gram, that will be the molar mass, isn't it? Fine, if you just cancel this stuff, you'll end up getting the number of moles, right? Let me do the cancelling stuff. First, let me cancel it out in multiples of 3. So you'll get like 2, 18 will be like 6. Here we'll have 4. And if I do cancel this one out, you'll have 1, 3, and then you'll have like 2. If I do one more cancelling into it, you will have like 6. That's going to be, yeah, 12, 6, 6.5. Got it? So the number of moles of carbon was equal to 6.5 moles. Okay, it should be clear. Next, I'll have to get the number of moles of hydrogen. So number of moles of hydrogen is just straight away 1. So number of moles of hydrogen will be equal to 22 moles, right? 22 grams, that will give you 22 moles. Now I just have to compare it with the unity. So I'll just divide it by 6.5 on both those number of moles of carbon and then the hydrogen. So this will go to 1 mole. If I divide it by 6.5, I'll end up getting the required number of moles with which it has attached to the carbon atom. Got it? So if I have to figure that one out, first what will I have to do is I'll just put in 22 divided by 6.5, isn't it? Yeah, 22 divided by 6.5. So 220 divided by 65. Let us make it this way. Yeah. So the first one, let me find it in terms of 3 multiples of 3. So 65 into 3, what will it give? 15, 1, 18, 195, isn't it? So here you'll have like 195, so 0, so that's gonna be 35, no, 25, 25. So here you'll have 3.250, isn't it? So here you'll have like 250, that will give you 65 into 65 into 4, something like that. 5 are 20, 2, 6 4s are 24, 26, isn't it? 24, 260. That's going to be slightly higher than this one. Therefore, you'll end up getting 3.3 or 3.4, something like that. 3.4 or 3.3. Got it? So, if I just divide this one by, yeah, if I just divide this one by 6.5, you'll end up getting 1 mole. For each mole of carbon, you will have like 3.4 moles of hydrogen into it, right? 3.4 moles of hydrogen. So when I have to get the empirical formula, I know I'll not be able to use decimal places into it. So let me do the approximation here. If it was like 5, then I'll have to find one more decimal place and I'll have to figure out whether it is like odd number or even number, right? We have learned all those things in significant figures in the physics. Okay, same logic will apply for the chemistry also. But anyway, here it is like simple. It is like less than 5. Therefore, if I round it off, I'll end up getting like 3, isn't it? So for each mole of carbon, you'll have like 3 moles of hydrogen into it. So that's the approximation that I could do over here. Therefore, the empirical formula should be equal to CH3. This is the empirical formula that should be there. Got it? So the answer here is option 2. Fine, easy sum. Only tricky part is you'll have to do the division properly, or else you might end up getting 3.6 or something like that, and you'll end up marking CH4, right? You shouldn't have any doubt on this question. Let's move on to the next one. This sum is a little bit tricky. Let me read the question. Here you have got what mass of 95% pure CaCO3 will be required. Okay, so you have got like calcium carbonate, which is 95% pure. Fine. So what mass of this calcium carbonate is needed to neutralize 50 ml of 0.5 molar HCl solution. So you have got an 50 ml solution which has a molarity of 0.5 mole, capital M, okay, HCl solution according to the following reaction. So they have given you the reaction straight away, so that will be handy. Got it? So here I have taken like calcium carbonate, and this calcium carbonate is like 95% pure. It's not 100%, it is only 95% pure. I need to use this calcium carbonate to neutralize this HCl solution, isn't it? Fine. So if I have to get that one, first I'll have to find in this 50 ml of water how many moles of HCl is there. If I get that one, obviously half the amount of CaCO3 is sufficient to neutralize the solution, right? So once I get the number of moles of this HCl, I'll be able to get the 100% pure number of moles of calcium carbonate needed. Once I get that one, I'll just match it with the 95% pure case, and then I'll get the required gram of calcium carbonate that was needed. Fine. Let me solve it. Once I do, we'll get it. First, my mission is to get the number of moles of HCl, right? So to get this one, what I will do is same logic that we have already done. So number of moles of HCl, this is what I need to find, isn't it? So to get the number of moles of HCl, what they've given in the question is you have got X moles in 0.5 ml, in 50 ml. So 50 ml is 50 into 10 power minus 3 liters. Same way, I'm just using the ratio logic, right? Then I know in 0.5 moles will be there, 5 moles of HCl will be there in 1 liter, isn't it? So this is the trick. Just do the cross multiplication and solve it. You'll get the number of moles of HCl that was needed. So x will be equal to 50 into 10 power minus 3 into 0.5, right? If I do the multiplication, you'll get 0.5 into 50, that will give you like 5 into 5, so you'll get like 25 into 10 power minus 3 moles. Got it? Now I have found out the moles of HCl that is there in the 50 ml of the solution, which will be equal to 25 into 10 power minus 3, isn't it? Right, so let me write that one over here. So you have got 25 into 10 power minus 3 moles of HCl. Got it? So if you look at this equation, it is pretty clear. Half of this mole is good enough to neutralize this HCl solution, because here the stoichiometry is 1, here it is like 2. Therefore, it is pretty obvious that half of this mole is good enough to balance this HCl, right? So half of that one will be 12.5 into 10 power minus 3 moles. Okay. Now, if it is like 100% pure, just multiply it with the molecular mass of calcium carbonate, you'll end up getting the answer. But here they have given you like only 95% is pure, right? So I'll have to tweak the equation accordingly to get the answer for 95% pure of calcium carbonate. Got it? Before that, what I need to do is I'll have to get the molar mass of the calcium carbonate. So to get the molar mass of calcium carbonate, yeah, for the calcium, I know the atomic number is like 20, then the then the mass number will be like 40. Okay, if that was the case, then molar mass will be like 40, right? So 40, and then with the case of carbon, it's like 12, obviously. Then for O3, that's going to be 48. Okay, if I do add this one, 2 plus 8, 0, 1, 8, 9, 10. So you'll get like 100 gram. So in 100 gram of calcium carbonate that I have taken, you will have 1 mole of calcium carbonate into it, right? So that's the condition over here. But what they're asking us to find is, it is only like 95% pure, right? So in this case, it's not completely pure, it is only 95% pure. So I'll have to formulate the equation in this fashion, which means 95% of this X, the calcium carbonate that I have taken, should be equal to it should be equal to 12.5 into 10 power minus 3 moles. Okay, if I have to convert it to gram, then I'll multiply it with 100 gram by its molecular mass. Okay, so only 95% is pure, so I'll have to put this 95% of this X. So X quantity is going to be a little bit higher because you are having impurity into it. You'll have to consider only the 95% of that entire mixture, because 5% is impure. If it was like 100% pure, I'll just do it straight away. But here it is only like 95% pure. Therefore, I multiplied it with the 95%. Okay. Got it? You should be clear with this idea. This is a basic math logic. We'll use this one more often in different sums. So I'll get used to this idea and notion. Okay. So 95% of the X should be equal to the number of moles that was needed, which will be like 12.5 into 10 power minus 3, and then its molar mass, which will be like 100, right? So if it was 100% pure, I'll just do it straight away, isn't it? X will be equal to 12.5 into 10 power minus 3 into 100. But here it is not 100% pure, only 95% of this one should be considered. Okay, so this value will be little bit greater, therefore 95% of this value will give you this term. If it was 100%, then the X will be little bit less. Okay, accordingly it will just change. So here they have given you clearly it is like 95%, so you have to be careful, right? Because if you don't use this 95%, you might end up getting the other answer. So there are like two close answers that if you don't use this one, you might end up getting some higher value. That is possible, right? So you should be clear with this idea that I'm telling you. Okay, so if it was like 100% pure, just multiply the molecular mass with the number of moles, you'll get the answer straight away. But here in this case, only 95% was pure. Then I'll have to consider only that 95% term. Then just multiply this 95% to that X. Okay, then obviously this X will be a little bit greater. That is when this left hand side will be able to match with the right hand side, right? You should be clear with this math logic that I'm telling you. Okay, I'll proceed it. Yeah, this is the only tricky part in this sum, right? So X should be equal to 12.5 into 10 power minus 3 into 100. Yeah, let me do this one. Yeah, 10 power minus 3 into 100 will give you like 10 power minus 1. Yes, right? So 95 by 100 will give you 100 will go to the numerator, 95 will be in the denominator, isn't it? Yeah, just I'll have to solve this one to get the answer. That's it, finished. Yeah, yes. Let me do one more cancelling over here. So 95 will give you 19, isn't it? Yeah, 19. Same way here. You will have like 2.5. Yeah, right? 10, that's going to be 2.5. So 2.5 divided by 19. If I just solve this one, you'll get the answer. Yeah, that too, this 0 and this one will get cancelled out. 10, that's going to be 25 divided by 19. Okay. So if I just solve 25 divided by 19, I should get the answer. That's it, finished. 25 divided by 19. So, isn't it? Yeah. So you'll have like 1.19. So this will be 660. 19 into 3. Let me check. What does it give? 27 to 57. Yeah. 57. So that will be like 3. 1.3. Then you've got like 3. Let me put 0 over there. And then 1.31 or 32, something like that. That should be my answer. 1.31 or 32. Okay, obviously. The answer here is option 3. Got it? So the answer here is like option 3, which is like 1.32. Fine. You should be clear with this sum. Here, if you don't consider this 95 percentage, it is more likely that you might end up getting this answer 1.25. So you'll have to plug in that 95 percentage over there. Okay. So this idea and notion should be clear. So the way I solve this sum is, I just found the number of moles of HCl in 50 ml of the solution. That's it. That's the easy part that we most often do in this kind of sum, right? So once I get that number of moles, what I did is I just need to find out how much amount of calcium carbonate is needed if it is 100% pure. It will be like half the amount of that one, right? So once I get that amount, I'll not be able to multiply directly it with the molecular mass because only 95% of that compound is pure. Okay, so 95 percentage of x should be equal to that term, right? Once you solve that one, you'll end up getting the answer. If you just plug in x straight away, just approximating it, you'll end up getting the other one in this option. Most probably you may get like 1.25, right? So you have to be careful while doing this sum, right? You shouldn't have any doubt in this question. Everything has to be clear. Let's move to the next one. This question is also a simple one. Here you have got, in 1 molar solution that contains 0.5 mole of a solute there is. So I just need to get a 1 molar solution, okay, and then the solute over there is like 0.5 mole, that is they have given you. What I need to get is how much amount of solvent is needed, right? First I need to know the formula for the molality, right? So the formula for molality, yeah. So the formula for molality will be equal to, what is it, number of moles of solute, isn't it? That will be in the numerator divided by mass of solvent in kg, right? So you'll have mass of solvent in kg, isn't it? So here they have given you the molality. So the molality of the solution is like 1 molar solution, which has like 0.5 solute in 0.5 mole of solute into it, right? So number of moles of solute is going to be 0.5 divided by mass of solvent in kg, right? So mass of solvent in kg actually means here this stuff is the x that I need to get, right? So if I have to get this one, x will be equal to 0.5, that is like half kg. So this should be the mass of solvent that has to be there to produce 1 molar solution with the help of 0.5 mole of the solute, right? So half kg solvent is required. So half kg is nothing but the 500 gram solvent over here, right? Simple sum straight away. Just if you know the formula, you'll end up getting the answer straight away. Got it? It should be clear. Let's move on to the next question, which will be the final one for this chapter and also for this session. This sum is also simple one. Let me read the question. You'll get the answer straight away. The right option for the mass of CO2 produced by heating 20 gram of 20% pure limestone. So here having a limestone, I've got a limestone that was like 20 gram and it is only 20% pure. Got it? They've given you the reaction straight away here. So limestone is nothing but the calcium carbonate. I'm just going to heat it and then I end up getting calcium oxide and then the carbon dioxide, right? What I need to get is how much amount of carbon dioxide, what is the mass of carbon dioxide that's going to get produced, right? If the 20 gram is 100% pure, then I'll have to get how many moles of carbon dioxide to get emitted. Okay, here only like 20% pure, right? So I'll just multiply it with 20% to get that 20% of carbon dioxide. Then if I get the gram for that mole, I'll end up getting the answer, right? Simple sum, straight away sum. First, I'll have to get how many moles of calcium carbonate is there in 20 gram of calcium carbonate. Okay, so to get that one, I need to know the molar mass, isn't it? I've already found in the last sum, which will be like 100 gram. Okay, so here as I know the molar mass, I'll be able to do it straight away. So here I just need to find the number of moles in 20 gram of the calcium carbonate. Okay, by the way, I know that in 1 mole you will have like 100 gram. Yes, so here the number of moles of calcium carbonate will be equal to 0.2 moles. Okay, so in 20 gram of pure calcium carbonate, you will have 0.2 moles of calcium carbonate, right? Molecules of calcium carbonate. But in the situation, that is like only 20% pure, which means you don't have like you will not have like 0.2 moles. You only have 20% of 0.2 moles. Same logic. Okay. So if I have only 20% of 0.2 moles, then 20% of 0.2 mole will give you the required calcium carbonate in this condition. Okay, so that will be equal to 0.2 into 0.2, isn't it? So 0.2 into 0.2 will give you like 0.04. So you have got only 0.04 moles of calcium carbonate over here. So this will only produce carbon dioxide, right? So what they're asking us to find is the mass of the carbon dioxide that got produced. As the stoichiometry is same, here also you will have like 0.04 moles of carbon dioxide that got released. Got it? So for the carbon dioxide, I know it is like 44, right? So if I just multiply it with 44, I'll get the answer. So that's gonna be 0.04 into 44 gram. That will give me the gram of carbon dioxide that got emitted. So 44 into 4, right? 4 4 are 16, 176, right? So 1.76, that should be my answer. So here is 1.76 gram will be my answer. So that is like option 3. Fine. So you shouldn't have any doubt on this question. This is a simple, straight away, easy sum, right? So you should be clear with all the pattern and type of sums that we have solved. So majority of the sums were related to the concept of moles, molarity, and those stuff, right? You also get like little bit tricky question from this chapter. This is the first chapter of chemistry. In this chapter, out of all the chapter in the 11th standard, this chapter has the more mathematical solving, right? So rest all other chapters will be much more easier than actually this chapter. Fine. The concepts will be less, but while doing some, you'll have to do more amount of math. That's the problem. Got it? You shouldn't have any doubt in all the sums that we have discussed. It should be clear. With this, the video gets completed. Bye.